All right. So hello and welcome everyone. We'll now be starting with the today's discussion, which is about asynchronous task processing in the cloud. And I'll be sharing my screen and I'll be walking through a few points over slides. So let me first start with that. Let's get started. So basically today's topic is async task processing. I'll not call it asynchronous. I'll use the word async. The and I'll try to explain the terms that I'm talking about as we go forward, but it's mainly a straightforward topic. Let's dive into it without me rambling. Okay, so what do I mean by the word task, or sometimes I like to call it a workflow? So basically, we are aware of software development in different ways when we are in a college or when we are just studying. We know about writing, how to write websites, how to build apps, how to build a UI for these things. We also learn, those people into dev, they also learn how to write backend services, APIs, REST APIs, etc. These are some things which most people are exposed to, but there are a lot of other things that go into writing software. So at times, I think most of the part of any software is the work that is done in the background, the processing part, where there are lots of small interactions going on in the background which you are not aware of. So let's say, for example, when you try to book a cab, right, through Uber, what you're interacting with is just the Uber's application, but there's a ton of things that are happening in the background. Like, for example, there's a map service that is running. They are trying to, there's location related services, there's pricing services that they're running. They're trying to dynamically fluctuate or change the prices, trying to find out or gauge the demand in that particular zone or area, and they're doing a lot of analytics, so on and so forth. So a lot of processes are going on that are not directly visible to the users, that are not directly even delivered to the users at the end. Um, but they are happening there. There's a lot of data or requests that are being processed. So a task is basically a series of steps that are involved in processing a given request. And here I'm mostly talking about something that is done in background, something that is not very visible to you as a user, but something that is core and fundamental to completing that particular request that is submitted. And it's divided into steps or subtasks that makes a complete workflow. So essentially, that is the idea of a task. Just a sec. Yeah. So that's a task or a workflow. It's a series of steps that you need to complete. And that's that. Now, some examples are listed here. First is a data processing pipeline. This is a very common kind of a task. It's a very generic thing that I've written here. And it could be anything, right? It could be a complete data analytics pipeline where you ingest your data, you do a lot of things on your data in between, run machine learning modules, run statistical modules, run cleanup modules, and then at the end you get some data that you want to report or you want to put it to your database, etc., etc. So that's a generic idea of a data processing pipeline. This is a key component, right? With almost every system today, you require some kind of analytics. There's some kind of feedback system. There's some kind of notification systems. There's some kind of events happening around, right? When you sign up on a platform, you are sent a mail, you are given this, that, certain things are set up for your account, etc. So a lot of these pipelines are happening in the background. They're not directly responding to an action of the user. Another example is a video processing pipeline. So let's say you are hosting an application where users can upload some kind of video, and you are giving them a service that you will make 5 different variants of this video based on certain criteria, right? You want to make like a teaser video out of the entire video. You want to extract the important slides from that video, something like that. You're giving some variants to the users. How would you do this? How would you enable creation of 5 variants of a video when it's submitted, right? Um, then another example is scheduled tasks. So things like reminders, things like notifications, things like report generation, right? If you are someone who is working on reporting of analytics, it can be manual, but a lot of times you might want to automate that process. You might want to do it every week. You want to generate a report every week. For that, you might have to pull in data from 5 sources, do something with it, generate a final PDF, send a mail to 5 people or whatever, 15 people on a mailing list, and you want to do this. So these kind of tasks or workflows are what we are going to discuss today. That's what's today's session about. And also, if anyone wants to ask any questions or interrupt me in between, I'd be happy to take the questions. You can stop me anywhere and you can ask whatever you want. So I think the stream is live on YouTube as well. Uh, there is a YouTube chat going on. I am not looking at the chat right now. I think some coordinators might help me out with it, and they can convey the questions. So the coordinators around here, I'd request you guys to look around in the chat if there are any questions, and you can stop me in between and you can ask the question. That's totally okay. Okay, so let's move to the next part. What are some of the things that are involved in building such a pipeline? I'll just use that word very loosely, very generically here. So there are multiple components, right? When you're building a data processing pipeline, there can be 5 modules. And like, for example, something that pre-processes your data, something that runs some kind of an analytic engine on it, a different kind of algorithm on it, etc. There could be multiple such components or steps involved. So generally, that's what a workflow is. Now, how would you do this? Like in a conventional world, how would you go about building such a system? Not a conventional word, but in a naive sense, let's say. So, in a naive sense, you could start by writing a single huge code base that has multiple folders and directories and files into which your code is organized, and then you make a ton of function calls. You host this code on a server. People can request, they can hit a request on your server, and then you do the processing. You return a response or you complete your processing, whatever. But it's a bunch of function calls across modules that you're doing, and you're trying to process this. Is this a good idea? Let's find out. So this is not actually a great idea. There are a lot of problems with this kind of a model. One is, first biggest problem is separation of concerns. This is an important idea in software development where you want to write modules that do one and only one thing, and they do it perfectly. That's sometimes called single responsibility principle, and you want to separate out your modules into doing one thing and one thing alone. Why is that good? For obvious reasons. One is it's easy to target if there's a problem, right? You can locate which module could be having a problem because they are doing only one thing. So you could find that out easily. Second, it's easy to develop them. You can develop them as entities, you can grow them, and you don't have to worry about interrelated service growing with them. So you want to separate out these concerns. It's lightweight. It's better to have a small module do something rather than a giant module do 5 things. So this is the first point. It's not good to dump everything in a single code base because there is a possibility that you will blur your separation of concerns. You'll tend to overlap. You'll tend to build cross modules, something like that. Again, a good software developer might not make these mistakes, but it's just so tempting sometimes to do it because it's easy. And again, the second point relates to it. Clear boundaries are not defined, and it's prone to error. And the error detection is difficult, right? If one module is doing 5 things, you now need to know how to do the error detection. That is difficult, right? Because you don't know what part of the module is failing. Where is the actual problem? Uh, Third point, difficult to develop or grow individual components. The thing is, your components are highly interlinked. They're highly cohesive in nature. So sometimes what might happen is in developing one module, you might end up changing 5 modules because those 5 modules are dependent on this. There is no clear interface sometimes. And again, all of these problems can be mitigated by actually following very good software development practices, but it's harder done than said. So that's that. It can be less fault tolerant. What do I mean by fault tolerant? So let's say you have 5 modules. You're calling the second module from the first, the third from the second in a series, basically. What can happen is that when a request comes, if it fails at the third module, your logic might not be able to resume from the third module, right? You might just have to rerun the entire request. This is not fault tolerant. It breaks your system in between. You have to do extra work. It's not able to resume from there. So that is it's a challenging thing to design a system which can resume from a failure, where it can start from where it stopped. That's another challenge. And the most important last point I'd like to stress more on, a lot of times these different modules are doing different kinds of tasks. They are not simple calculations. Some of them are intense. Some of them are, as I said, machine learning models. Maybe they are doing something complicated. It's taking a lot of time for them. Some modules are quick, lightweight. They are taking lesser amount of time. So there is a variation in their throughput. That's a term I'd like to use. Throughput is basically the rate at which some kind of requests are being processed, something like 1,000 requests per minute. That's a throughput. So different modules have different throughputs. But if you try to make them work together, if you synchronize them, they tend to be bottlenecks in your module. And certain modules, even though they have a higher throughput, they are able to run faster, you are limiting their capabilities by forcing them to be synchronized. And I'm using this word on purpose, synchronized, because now we are going to look at the idea of asynchronous, right? So just to touch upon, synchronous is basically the idea where you synchronize your actions. You're trying to synchronize the execution of all your modules one after the other. We want to avoid this. We don't want to force the modules to run one after the other in sync. Sometimes it's necessary. Sometimes it's actually important to do that. But a lot of times you don't care about them running at the same time. You are okay with some delay because it's a background task. So things like this can be there, which we want to mitigate at the end of the day. So just 1 second, I'm sorry. All right. Moving on to the next slide. Can we do better? Yes, the answer is of course we can do better, because we pointed out a lot of problems, and let's start solving each of them one by one. So the first thing is, do not dump everything into a single code base, right? For prototyping, that's okay. You're testing your idea out. That's all right. But if you're doing something in production, if it's going to be used by a lot of users, if it's a high velocity, high throughput system, you don't want to build everything into one code base. Separate the system into independent components. Build separate components that are independent, almost standalone, following the single responsibility principle, following the separation of concerns. That's the first thing. Make different repositories. If you don't make different repositories, okay, you can follow a single mono repo, but deploy your services separately. Don't deploy it into one giant running application on a server or a single thread or process, whatever. So separate them out into components. Second is define clear interfaces to communicate. So a backend and a frontend system is exactly like that. They are communicating through an API. API is a well-defined interface for frontend to request something and the backend to serve that. Same goes for your modules. Define clear interfaces to communicate. And I'll touch upon this. How are we going to do this? But yeah, so the idea is you want to separate them out. Don't do crude function calls. Define interfaces that each module can access. And if your implementation changes over time, that's okay. The interface should remain constant. Third point, which is one of the core ideas of today's talk, is make the tasks async. Make the tasks async. Asynchronous is something that we are going to focus on. And the idea is that you want them to not run in sync. You want them to run separately, allow them to grow, scale independently, and do not force the modules to run one after the other. That's the idea. How to do this? So the next point actually introduces an idea that allows us to make things asynchronous, makes the communication asynchronous, and it allows us to develop systems into independent components, run them independently, and so on. So the idea is introduce a message exchange, to not force them to call each other via function calls or etc. Rather, allow these modules to talk to each other by passing messages. Now, what I mean by that, a function call seems like a message, right? You're passing something to a function. But the problem with a function call, or even the problem with a REST API or a gRPC, RPC call, is that when you make the call, that process has to respond within some time. And you're blocking your own process. In a lot of cases, you're blocking your own process and waiting for it to respond, right? So that is the idea of synchronizing, and we want to go away from it. So we want a message exchange on which people can put their messages. Some modules can produce messages on the exchange, and some other modules can consume those messages. And via these messages, they are talking about what tasks need to be done. So if I give an example, let's say you have to fetch data from some API, then you have to process that data, and then you have to push it to database. So there are almost 2 to 3 modules running here. So let the first module independently pull data from the API at whatever rate it can, right? It could pull 1,000 records every second, or it could pull 1,000 records every minute, whatever be the rate. Your second module need not match that rate, right? The first module will keep on pulling the data, and it will keep on publishing it onto this exchange. And the second module, whenever it is ready to process these messages, it will read messages from the exchange and carry out the tasks. So that is a simple idea of the message exchange. It decouples your systems. The words that I'm using are quite important here. The idea of decoupling, the idea of systems being asynchronous, independent. These are the major designs that allow your systems to scale. You need a system that is decoupled, which makes it fault tolerant and scalable, and it should run asynchronous. I'll give a real example on something that I worked on. So initially, I was working with some startup, and I was supposed to design some kind of a scraping system where we were supposed to scrape like hundreds of thousands of records from different websites, and we built a simple single code based system. It took literally 24 hours, like almost a day, to scrape over 100,000 records. A single code base, everything running in sync. A bad idea. It was okay as a starting point. We optimized it to use such a system that is described here, and we got remarkable results. Like within 2 or even 1.5 to 2 hours, we were able to scrape over 200,000 records, which was insane. So that is what you can achieve with these kind of systems. Moving on. So I talked about the idea of a message broker. Message exchange, it's called message broker. So message broker is basically a middleman. It enables different services and components to exchange messages, right? You can produce and consume messages. You can produce messages which other systems will consume, and you can consume messages from other systems and do something. And you use this sort of a middle layer of communication to accomplish such end-to-end processing that we are going to talk about. And the second point is something that I was talking about, which is it effectively decouples your system, and it introduces asynchronous communication between modules in the system. Very important terms. I cannot stress this enough. Someday, if you are going to write a system that has to scale, these are the very fundamental principles that you would be using to scale a system. So decouple your components, decouple your system. Do not keep it tightly synced and make it asynchronous. Now, message brokers are just exchanges, but there are different types of patterns when you want to exchange your data, when you want to exchange these messages. And a few of them I've listed here, and we'll just take a brief peek into them so that you're just aware of these ideas. The first pattern, which is a very famous pattern, it's called a pub/sub pattern, which is publish, subscribe pattern. And as the name suggests, you can imagine there are publishers and there are subscribers. So it's literally what it sounds like. There are certain modules, there are certain services in your system that are publishing messages on this exchange. And then there are certain other modules that are sort of subscribed to a channel. So you publish onto a channel and you subscribe to a channel. And whenever you are subscribed to a channel, whenever a message is published on the channel, you will get a copy of that message. It's a broadcast kind of a mechanism. You're broadcasting your message to everyone subscribed to that channel. It's called a fan out pattern because you can imagine that there are messages coming in from one end, but they are fanning out. They are broadcasted outwards to all the consumers that want it. So I'll try to describe it in detail, but this is a basic idea of a pub sub pattern. The next is the one that we are going to focus in this talk on, which is the message queue pattern, where the idea is that you're not broadcasting your messages. What you're doing is, okay, let me change the slides and talk about each one of them. I think that would be easier. Okay, so the first pattern, if you can see here, this is a publish subscribe pattern. This cylindrical thing is your message broker. It's like a pipe because people imagine it like a pipeline or a channel sometimes. So P1 is a publisher putting a message M1 onto this channel, and C1, C2, C3 are consumers that are subscribed to this channel. And whenever a message is put on the channel, a copy of the message is received by each and every subscriber. So it's not one copy per subscriber. No, everyone receives the same copy. It's broadcast. Now, a very nice example of this would be, let's say, user logged in for the first time in a system. Registered on a platform. You might want to do 5 things with that. Right? You might have, let's say you want to set up notifications for the user. You want to update certain records in your database. You want to, fetch some information about the user. You want to do like a bunch of things when the user onboards onto your platform. Each of these things can be a separate module, right? C1 can be a module that takes care of notifications. C2 can be a module that takes care of pulling the user information and pushing it to database, something like that. C3 can be a separate module. And each of these modules are getting a copy of the message that contains something about the user that just onboarded. And each of these modules are actually independent. They are not dependent on each other. So when you want to do something with a single message, and when you want to do multiple things in parallel, you use a pub sub pattern. It's a fan out pattern or broadcast pattern. So that's the idea. The next thing is a message queue pattern. So message queue pattern is, as I said, what we are going to do today. But the idea is, again, there's a queue. Now, this is a queue of messages. This is important. A queue is a FIFO data structure, first in, first out. And it's more or less followed when you are implementing a message queue. So these message brokers are just softwares that enable something like this. When you push messages onto the queue, they maintain the order of the messages. And what they will do is, in case of a message queue pattern, they will deliver a single message to an instance of a consumer. They will not broadcast a copy of message to everyone, but they'll hand a single message to every consumer. So it's like a one-to-one mapping. Like one message is consumed only by one consumer. That's a key difference. When you would want to do this, you can do this in the examples that we are going to talk about, right? So when you have a sequential processing where the modules are dependent on each other, they are not running in parallel, they are not doing independent things, but they are dependent on each other, but they want to do something one after the other. So, so the example in our case could be about, let's say, some kind of video processing. You want to first do some kind of basic processing on the video, then you want to do some elaborate processing on it, and then filtering. I'm not a video person, so I cannot say what's the thing. But yeah, so let's say that's an example. So the consumers would be separated by these message channels. So the first producer would put some message onto a channel. A consumer would pick a copy. It would do its processing, put it to a second channel. The second one would take it up, do its processing, put it onto a third channel. So you have multiple queues actually, and these queues are separating your consumers or separating your components. And that is the basic idea of message queue pattern. Sorry. Yep. And the third one that I described here, and I've actually not put a slide about that because genuinely that is something that is utilized less. It's called a fan in pattern. I'll just briefly talk about it. So basically the idea is there are multiple publishers, but there's only a single consumer trying to consume all of it. This is something that can be useful when you want to ensure that there's a strict order in which things happen. And nothing gets left out. So you want one consumer to be like your watchman and do something for you. So it basically fans in. There's an inflow into a single consumer. So that's a fan in pattern. Honestly, I have not utilized this pattern ever in my usage till now. I've used the other two patterns and they are pretty useful. Okay, so moving on to the tools, right? So I talked about these message brokers. I talked about these patterns. What are the tools that we can use? There are a lot of tools out there. So a few of them are listed here. Rabbit MQ, Active MQ. MQ stands for message queue. So Rabbit MQ is pretty famous. It's an open source tool as far as I know. And you can, so just like you have a database service or you have just these kind of softwares, you can install it and host an instance of RabbitMQ, and you can run a message broker on a server. Kafka is very famous by Apache, and it has this idea of topics. I'm not going to details of each of these services because that's not the aim here. Kafka, then AWS has amazing services, SQS and SNS. So SQS is the one that we are going to use in today's talk, which is simple queuing service, and SNS is simple notification service. So one of them is more PubSub oriented. So SNS is your PubSub pattern. It's a notification pattern. And SQS is your queuing service. Azure Message Bus, again, that's an Azure offering. Then Google PubSub, Anypoint MQ. So these are some example tools. Let's go to the next slide. So today what we are going to talk about, it's supposed to be a hands-on session, or at least I'll show you or walk you through a code base that implements this idea. But for today's example, we have a very simple data scraping pipeline in front of us. And this pipeline is short because it's an example right now. And I just want to put it out as a disclaimer that what I'm going to show is not going to be best practices, most optimized stuff, because that's not the goal. The goal is to introduce these concepts, these ideas that you can go and use and get started with in some application that you might have. So yeah, the example that we are showing here is a data scraping pipeline where we are using, so about the symbols here, we are going to do these things on AWS Cloud. And this diagram that you see here is basically the symbols for AWS services. And I'll try to describe these services one by one, but yeah, just bear with me for a little while. So the first diagram that you see, which is queue containing links, this is basically a queue. This is one of the queue of your message broker service. We are going to use SQS, which is a simple queuing service. And there's one queue that's going to contain links. These links are going to be the links from where you want to fetch your data. That's the idea. Then you see there's a Lambda symbol because that is literally what the service is, AWS Lambda. It comes from the idea of Lambda functions. So Lambda functions are something used in programming languages in general, like C++ or Java, etc. The idea of a Lambda function in AWS is these are event-driven functions. You trigger these functions, they do some task, and they exit. Very simple. I'll touch upon this. This concept is called serverless processing, and I'll try to describe what that is. But for now, think of it as a module. It's a module that is going to do some processing on our data. So there's a queue that contains links. Now, how are these links coming in the queue? You can talk about it as a part of your system. Maybe it is something where you load the queue with links beforehand, or every 5 days you load the queue, or something like that. You could do anything with it. We'll just assume that this queue is loaded with links somehow. Then there's a function that is going to pick links from the queue, process them, and whatever output it has, it puts in the second queue. So that's the second queue besides there, the queue containing the scraped data in JSON format, could be anything. So the second queue contains the data that is fetched. Now, here you could be imaginative and you could do anything with the data, right? You could put a data analytics module that does something with your data. You could put in some kind of a transformation module that transforms your data, and you can do a bunch of things. You could have like 5 other modules in between. But as I said, for the sake of simplicity, we are having just another function that will take this data and push it into database. So on the rightmost side, you see this DB. DB is your database. RDS stands for Relational Database Service. We'll talk about this, but this is your database. And then simultaneously, we are also pushing to Elasticsearch, at least in this diagram. So Elasticsearch is a search service. It's a searching service. It looks like a database where you load your data, but it allows you to do textual search on your data. It's useful when you are building a search engine, right? So if you are having a catalog of something in your website and you want users to search through the catalog, you could use Elasticsearch for that. So that's the idea. Or attached to the queue, and they take messages and process things from the queue. That's all that the idea is. And now I'll probably be going into the hands-on session. But before that, if anyone has any questions, they could ask on YouTube chat or Zoom or whatever. And some coordinators could look into that and tell me. I'll wait for a couple of minutes. Till then, I'll stop sharing. Guys, anyone? I have the YouTube live stream open here. Okay. If nothing, then I'll continue and we'll continue the hands-on session, basically. All right. So I'll continue the presentation. There are a few more things that I want to just introduce before we get on to the session. Okay, so this is the pipeline that we are going to observe and look into how it's built. But before we do that, let's try to understand a few things, because some of you might be a little new to AWS and the idea of a cloud service, etc. So let's first look at that. So the core service that we are using to accomplish this is AWS. AWS stands for Amazon Web Services. So it's a company by Amazon. And what is AWS? So AWS is basically a cloud service provider. Cloud is essentially an idea where you have servers and physical machines hosted at a remote location, like in a data center, somewhere away from the users, away from you. And it is managed by a provider like AWS. So AWS manages some data centers, which has a ton of physical machines, like huge data centers, which have a lot of computational resources. And what they allow you to do is they allow you as a user to connect to that system and utilize these resources. And they will charge you some amount of money, or they'll charge you something for using their services. So they're essentially providing computation as a service. They're providing you with virtual machines, they're providing with servers, databases, etc. So that is what basically a cloud provider does. It's your computer away from you, not your laptop, but like some computing resource hosted away from you. So that's what AWS is. Now that was a very, very preliminary description, because AWS and even other cloud providers like Azure by Microsoft or GCP, which is Google Cloud Platform, they nowadays provide a lot of services. Like they not only provide you with access to virtual machines or servers, but they also provide you with object storage, right? You can store things like you would store on a hard disk. You can store files, etc. So they provide you with storage in the cloud. They provide you with relational database services. So you can host a MySQL server on their cloud service. They provide you with CDN service, content delivery network. So that allows you to host websites and serve your content across the world. They provide DNS service. They provide even some managed services like Elasticsearch. So they provide you Elasticsearch service. So they provide you something called managed services. The idea of a managed service is it's a service, it's software that you yourself could have hosted. You yourself could have ran on a server, but now you're not doing that. You are letting them take the headache of maintaining the servers, maintaining the infrastructure and everything. And you are only worried about your application. So they manage the infrastructure for you. That's the major goal of cloud services. It's basically a very sophisticated portal at the end of the day. That's how I like to call it. You can go on to AWS and you literally have to do 5 clicks and you can start running a virtual machine. You can start deploying your application. You can host your website in 5 clicks. And it's very simple. The only thing is that it costs you some money. As a student, you have some options. You can create an account that's free account or a student developer programs. I think there are programs that give you free credits. You can use accounts like that to try around and explore. For more advanced users who are obviously aware of AWS, it's not just a portal. It allows you to access it in a ton of ways. You can access AWS from your terminal, from your command line interface. They give you APIs. You can make calls to their services and do things programmatically, right? You can call AWS from your software piece and do something with it. They provide you with SDKs. SDKs are software development kits. So they're basically function calls, right? You could make a function call and it would do something on AWS. So it's very, very powerful. And this goes for all cloud providers today. Your GCP, Azure also provide with same capabilities. Here, I'm just talking about one cloud provider, but you can apply these principles on any cloud service. So AWS, let's move on to the next point, which is the ingredients for our pipeline. And there are 5 things listed down here. And I'll try to show these things in the AWS console as well. You call it a console. And just to get a feel of what these things are, right? So the first service, which is the glue that binds our modules, is your message broker. So as a message broker, we are going to use AWS SQS, which is a simple queue service. And it literally provides you with multiple queues from which or onto which you can attach your modules and do processing. Second thing is AWS Lambdas. So Lambda functions are basically functions in cloud. That is how you can call them. They're literally a piece of code that can run in cloud without you having to worry about anything. Literally, you don't have to worry about anything. You just submit a piece of code and you tell them that this is the entry point, and that's all. They will simply execute it on some condition. You just have to define a trigger, a when to trigger this code. And they will manage everything. They'll manage the scaling, they'll manage how to start the function, how to execute, end the function, etc. So this is a very handy way to deploy your modules, right? You could deploy a Lambda function as a module. And you could run that Lambda function on certain triggers. And we'll see how that triggers are set. But that's the idea of a Lambda function. Basically, it's your function in cloud. It's sometimes called function as a service because they manage your function execution for you. It's also called serverless computing because you don't have to worry about servers. You don't have to think about the underlying machine on which things are running. You don't have to worry about installing Node.js. You don't have to worry about installing an OS or anything like that. It just runs it for you. That's all. So it's serverless. It's scalable. It scales itself. You don't have to even worry about scaling. If they're like, uh, you have a requirement of 100,000 Lambda functions, no worries. Uh, is my screen share not visible? I am sorry if that was the case. Is it visible now? Can somebody confirm?
Yeah, it is.
Okay, I'm so sorry. I think I might have stopped sharing and then. So yeah, so this is the slide that I was talking about. There is SQS, Lambda functions. Um, Next is the serverless framework. So this is one framework that we are going to use. Um, the name is serverless. So what this does is it manages your resources on AWS. So it manages the creation of these Lambda functions, right? So how do you submit code? You can do it manually. You can go to the console and upload your code. You can upload a zip file, or you could have some kind of framework manage that, where you just write one command and it just takes care of everything. And that is what serverless does. It's very powerful when you want to build complex pipelines, because you don't have to manually go and manage your queue and then your database and then 10 other things in AWS. Serverless manages for you. And we'll use this framework. AWS RDS. So RDS stands for Relational Database Service, which is basically uh, just a MySQL or any relational database instance running on cloud. You don't have to think about installing MySQL on a VM and then starting it. You just make an instance of RDS and you are done. So in this example, we are going to use a MySQL instance, just basic plain database. There's something called CloudWatch. Again, this is optional for our experiment, but CloudWatch is the idea of monitoring your application. Monitoring is key. When you build scaled applications, you want to monitor every aspect of your application. You want to see what's going on. You want to check failures in real time. There are very complicated and beautiful systems around monitoring. We are not going to go into that, sadly, but CloudWatch is a service that allows you to gather logs and monitor your system. Basically, it's optional for this experiment. I'm just going to maybe use it. So yeah, these are the ingredients. Now I just want to show them on the cloud. So I'll stop sharing my screen and I'll put on a different screen basically. And yeah, you guys could tell me once the new screen is shared. Okay, just a sec. Okay, can someone confirm if they are seeing the AWS screen?
Yes, we are able to see.
Thank you very much. Okay, so this is how your AWS console looks like. As I said, it's just a portal where you do clicks and do stuff. It's simple. I'd like to go through the services that we talked about. So I'm not going to do a tour, honestly, because this is not an AWS tutorial. If you're not very familiar, I just suggest that at some point, please do look into how to use it. It's very useful anyway. I'll try to describe some basic things, but I'll not go into much details. So this is a list of all the services that AWS provides, which is a ton of services. And what I described was just 5 services that we are going to use. So I'll quickly dive into those services, but you can see here that you have compute services. These are basically servers. You have Lambda that I was talking about. You have other things. You have storage. So S3 is where you can store your files. So this is your file storage service. Database, you have RDS, which is relational database. DynamoDB, which is like your MongoDB. It's similar to that. It's managed by them. Other kind of databases. Then they also have things in networking. So you have API gateway. You have Route 53, which is your DNS service on AWS. Then what else? We have things related to blockchain. You can have a managed blockchain on AWS. Then governance and management. So CloudWatch is a monitoring tool. There are a lot of other monitoring tools out there. Other stuff. So yeah, let's dive into the first service, SQS. All right, so you can see a few things already created, but I'll just do a tour. So SQS is the message broker that we are going to use. It's going to have queues, right? You can create multiple queues. And what I've done here is I've created two already that we are going to use in the example. So if you remember the diagram, we had two queues and we had two modules. Those modules were attached to your queues. What do I mean by attached? I'll talk about that. But basically, you have these two queues in which we will put our messages, we'll put our data. And there would be some modules that are going to process data from these queues. You can create a queue very easily. You can just do create queue, and then you just have to fill out a bunch of configuration, very standard stuff, and you just create a queue. You don't need to change the default settings unless you know what you're doing. The defaults are good, in my opinion. Okay, let's go to the queues. There are two queues here, scraper links and scraper data. So the first queue is going to host the links from which you have to scrape data. And the second queue is going to host your data itself, from where you want to push data to your database. So that's the basic idea. That's all. That's what SQS is. But I'll like to show one small point. So you can open a queue and you can look at a few things. But there's something called Lambda triggers. So there is a Lambda function. It's not very pretty looking here if you see. It's just bunch of identifiers, random things written. It has meaning to it, which you will understand if you were to dive a little deeper into AWS. But so basically there is some Lambda function attached to this queue. This attach thing happens, you can do it manually. You can attach a Lambda function manually, like configure a Lambda function trigger. You could attach a function. Or what we are going to do is use the serverless framework to do this linking of a queue and a function. Now, what happens when you link a Lambda function to a queue? What essentially happens is whenever there is a message on the queue will trigger one instance of the Lambda function. Be careful with the term instance here. So if there are 10 messages, it will run 10 instances of the same Lambda function and pass each one of them messages. So whenever there is a message in the queue will call the Lambda function. It looks like a function call, but it's not a function call. It's some complicated stuff going on in the background, but it looks like a function call to us. So the messages would be passed on to these functions, and the functions would do something. We can write any code over there. You could do anything with the message. So what we will do is this particular Lambda function will take the link from this queue, the message from the queue, and then it will process it and push it onto the second queue that we have described here. This is the second queue, scraper data. This queue will get the second message, and then your second Lambda function, again attached to the queue, a different Lambda function. This Lambda function, it has some name. The name is this data scraping pipeline dev scrape data DB, some complicated stuff, mouthful to speak, but basically a function that will take data from the second queue, which is produced by the first function, and do some processing. In this case, it's going to push it to the database. So I want you guys to keep in mind the diagram that I showed you about the different components. So this is your second queue and the second function. The second function will push data to the database. So this is a simple pipeline setup. The beauty of this is your first function can produce 1,000,000 records in a minute. It's not going to, but hypothetically. And your second function can process just 1,000 records in a minute without any problem. Your queue acts like a buffer. It acts like a shock absorber. It's going to take excess of messages, keep it in the channel, and whenever there's a capacity, it will run the second queue, essentially. I'm sorry. So that's basically the idea here. So that's the idea of decoupling. You're decoupling your components, you're decoupling your system, and you're allowing your components to run independently and allowing them to scale, which is the beauty of an asynchronous pipeline. Okay, so this is Q. Let's look at the Lambda functions. So let's go to Lambda. Lambda functions are very simple. As I said, it's just a bunch of code that can be executed by a trigger. The trigger in this case is a message in the queue. That's your trigger. All right. So there are two queues and there are two modules attached to the queue. Each one of them is a Lambda function. The first one is attached to the first queue. And this Lambda function, we will see like a little diagrammatic representation. So you see here, this Lambda function is triggered by this queue. If you just click here, it will tell you what queue is it connected to. It's connected to this queue, which I just showed you in the in the previous thing. And you can add another trigger. You can trigger this Lambda function by something else also. Uh, and you can add a destination. We are not handling the destination part in AWS. We are going to do it manually in our case. Like we are going to write data to a different queue. We are going to handle that ourselves. And very similar to that is your second Lambda function. Looks very similar to that. The code is different, of course. The code does something. It's your module. You can write anything there. Again, a SQS trigger attached to the second Lambda. So, sorry, attached to the second queue. And yeah, you can close this. One second. There's something else as well that I just like to point out. Yeah, you can have a bunch of things here. So you can, the different configurations of this function, right? You can set a concurrency. You can say that I want only 50 instances of this function running at a time. Why would I want that? Because your database has a capacity of 50 connections, let's say. It cannot make more than 50 connections. So you don't want to overwhelm your database. So you can reserve concurrency. You can set some parameters like number of retries. If a message fails, how many times am I supposed to retry? The timeout of a message. The timeout of your Lambda function. Your function is going to be killed after a certain amount of time. Here, the default timeout is set to 6 seconds. Your Lambda function will die after 6 seconds. So if the task doesn't end in 6 seconds, it will die. You can change this. You can configure this to be minutes. Generally, it is preferred that you keep it low. You can configure the RAM you want for the function. You can configure the runtime environment. So I'm using JavaScript. I'm using Node.js as an example here. You can use Python, Java, C#, any language, and some other bunch of things. But yeah, this is how your Lambda functions look like. Last piece that I would like to show, I'm not going to show RDS because it's just a database server. You probably won't see anything. Um, but we'll look a little bit into CloudWatch because that is where we are going to look at our logs, logs that are about the data, the workings of what's going on. So you can go to log groups. It does a lot of other things, CloudWatch. Again, we'll not discuss that. But there are two log groups. One is of the first function. The second one is of the second function. And they are literally your server logs. They look like your server logs. You can open a log. It's time stamped. You can read through what was going on. So I'd done a trial run, of course, and I could see what's going on. So yeah, you can, so whatever you console.log in your applications, if you're using JavaScript, or whatever you print in Python, all of that is logged here. One difficult thing about cloud applications running like this is you don't have a terminal in front of you. If something fails, you have to look for the logs. You have to look into the logs and see what went wrong. So that's a little tedious to debug it, but there are a lot of nice tools to debug such functions as well. All right. So let's try to dive into the code and let's see what's going on. So I'll stop sharing this section and I'll share the code. Okay. I think the code editor is visible now. So yeah, since we are not very high on time, I think it's 7 already, and I think I'm supposed to wind up the session in like next 20-25 minutes. I'll probably not be able to code things from scratch because whatever the setup is, if from the point of view of code, it's not very simple because there are a lot of moving pieces. So I'll try to walk you through what we are doing here. Uh, Basically, this is so the framework that we are talking about, serverless framework is, at the end of the day, it's just managing resources on AWS for you. So it does not have any specific code. What it has is a configuration file. So there's a file called serverless.yaml. This file contains the configurations. It contains the information about whatever resources you want to use on AWS, and it will go and provision those resources for you and deploy your code onto that. So how to do that is, I'll just try to open a new terminal and let's see. I'll show you what we can do. It's very simple. You just have to install serverless first. So you just have to do npm install serverless -g, which is globally install serverless. So it's literally npm install -g serverless. I already have it installed, so I don't think anything would change. It's a node package, so you basically want node.js installed. I just end it here because it might take some time. So npm install, then you have serverless installed. Now you have a command called SLS, which is short for serverless. And then you can do something like SLS create -t AWS. Okay, so let's first make a directory. Let's see where I'm standing. Okay, let's make a directory here. Test, I'll just make a directory. And inside this, just a sec. All right. So inside this, we will create our application, the serverless. We call it a serverless application. So we'll do SLS create -t. T stands for template. So you want to use a template. So let's do SLS create minus help. Let's see what shows us. Why is it stuck? All right, so that was a little slow, but okay. So you basically can create a serverless project, a serverless service. And what do I mean by that? So basically, when you pass the create command with a template, -t is for template, you can pass different templates. Serverless is platform neutral. It works with AWS, it works with Azure, it works with GCP, it works with even random things like you might not have heard of, even I have not. So it works with a lot of platforms, and you can create a project. So you can use AWS Python if you want a Python based serverless project for AWS. Same goes for AWS Node.js, same goes for AWS Go, or you could do Azure Node.js, you could do Google Node.js, Google Python, Google Go, whatever. So there are a lot of options. Serverless is very battle tested by now. It's a good framework and reliable. So let's create a AWS Node.js based project. So you'll do SLS create -t, and then you just specify the template that you want to use. So this will create something, as you can see, it will create some kind of a boilerplate in your folder. So we are standing, if you do PWD, we are standing in this folder called test, because I'm just testing this out. And here it created some files. So if we see, it created two files for us, handler.js and serverless.yaml. So they create this YAML file for you, and then you go about filling it out, right? So let's do something. All right. So this serverless file, I try to show you what it is. I'll open it in a editor here. I'll not open it in Vim, in VS Code. So Vim serverless.yaml. All right. So it looks like this. There are a bunch of configurations defined here. You define the name of your service. This is like one entire service with multiple modules that you want to manage. So our entire pipeline can be managed by one project. Then you describe certain things like the provider you want, the runtime. So I'm using Node.js 12. You can define other things like it can be a dev environment, it can be a production environment, stuff like that. You can define the region. This is the AWS region. Again, some AWS specific information. Here they are putting it. Then functions. So these are the functions that are going to be deployed on cloud. So you just define the name of these functions. And what serverless will do is go and create those functions on AWS. It will go and create the Lambda functions. You have to tell the handler. The handler is the entry point of your code, right? You have to tell it what file and which function. So I'll show this, how we decide this. And then some other bunch of stuff. So this is how an empty serverless file looks. And we have to then populate it. So let's see how we have populated our serverless file here. So basically the service is, you can give it any name, your wish. I'll skip this for a minute and then I'll talk about this, but there's a plugin. The provider is AWS. The runtime for me is Node.js. I'm using a dev environment. Again, this is a descriptive name. You can write anything, but I stick to dev if I'm doing something for the first time. The region, which is AWS region, AWS has a lot of regions. This is basically where your resources are going to be hosted. So it's going to be hosted in US West 1. So there are 4 major regions: US West 1, West 2, East 1, East 2. US West 1 is North California. I don't think that's how comments work. Okay. This is an AWS region. The most reliable region in my experience, I mean, all are reliable, but something that I find to be the best is US East 1, North Virginia. Reason being that any new service of AWS almost always is launched first in US East 1. So if you want to try out something cutting edge, US East 1 will probably support it. It's in a rolling fashion. Not all the regions get all the services, but most of them have the essential 80-90% of services. So that's your region. All right. Package individually is to true. So what this will do is this will make separate zip files for each functions that we define and deploy separate zip files, not one big zip file of all the functions. So we want to define functions, Lambda functions. So we are defining 2 functions, data scraper and scrape data DB, right? The first function will scrape data based on links. The second function will push data to the database. These are descriptive names. You can use any name that makes sense to you. Then the handler. The handler is the file and the function that is going to be the entry point. So whenever somebody executes the Lambda, whenever there's a message in the queue, your SQS will spin up an instance of this function, call this function and pass the input to that function. That is how it works. We'll look at this file. Events. So now this is where you are basically attaching your function to an event. You saw the trigger in the AWS console. The trigger is this event. The event is SQS. We are saying that I want to attach this handler to an SQS queue. The queue is defined here as a variable. So I'm using some environment variables for the queue. Basically, you can just create a .env file and you can put your queue URLs here, your queue ARNs. Just ARN is a Amazon resource number, which is a unique identifier. It's like an ID. So yeah, you can use anything like this. All right. So basically you are saying that I want to attach this function to this queue. This is all that you have to do to attach a Lambda to a queue. And when you will deploy this, the Lambda function will be created. It will be attached to your queue and everything will just work like magic. The second function goes same. So this is your serverless YAML. It's a config file. You just define it. I am not going to do a detailed code walkthrough because that's not the goal of this current talk, because it's not about the code. It's about explaining the idea. but I still like to talk a little bit about what we are doing. So services, again, this directory structure is something that is according to you as a developer. You want to create according to your requirements. And this is according to my requirements here. So my general style of writing code is I'll create a config directory that houses all my configurations, one single point. This is not the best practice. There are better ways to manage config, but for now, this is okay. Lib is where you have all the common code, library code basically that you're going to use across different modules. So things like SQS. I am going to call SQS maybe. I'm going to call database. I'm going to call file system. So I'm just writing utilities, right? We can have a look. So this db.js has a function called write to database. This is going to be called by someone. Someone will call write to database and then all of this will happen. So this is your db.js. This is common code. Any module can call this. So the idea of lib is common library code. Models like your normal models. So our application is collecting data from a website. Now we are going to scrape online MOOCs or online, course providers, right? So that's the example that we have taken. So we have courses. So I've defined a model of course, right? You have course ID, title, description, provider, author, a lot of things. We are going to store this in the database. We are going to store this object in the database. So the other things like the categories, the providers, they are not filled out because you don't need it here. It's an example. Your scrapers are the scrapers that are going to scrape the data. So you have Udemy. So I'm going to use Udemy as an example. We are going to call Udemy's API to fetch the data. We are going to call it. We are going to create a course object. So I'll do a little walkthrough. We are going to call an API here. This line does the API call. We are going to call an API. The data URL will come from some configuration. So you have data URL, you will get the data, you will iterate over it, you will create a course object, you will fill in the details, basic stuff, and then you will call this write out. Write out will write this JSON data to the second queue. So write out is implemented in data scraper. So this is object oriented code. It is built using good practices. So I am extending Udemy data from data scraper. It's hierarchical. So Udemy data extends this data scraper. So data scraper has a write out method, which all scrapers will use, right? Every scraper is going to write out. So here in write out, you can see we are going to write to SQS. We are going to write to the second queue. We will write the data onto the next queue from where it will be processed further. So I'm just doing a very rough walkthrough because I can't explain the entire code base at this stage. So these are scrapers. These are the services. So the Lambda functions that were attached here are residing in my services folder. So services slash this function. So let's open it. And there's a handler. The SQS event will be passed to this handler. The message will be passed to this handler. The handler will do something. So here, if you just do a brief run through, it just iterates over the message and messages, and then it calls a scraper. It passes some runtime configuration to the scraper, and you call scraper.run, which will run your scraper code. It will return the response, and you have finished scraping. This is just some code we don't care about, but you are going to run your scraper. That's the idea. Yeah, so that's pretty much about the code. The services handle this. Scrape data DB handles the database side of things. We are going to get the data in the second queue. The second queue will call the handler. It will pass the event, and now our handler will do some processing. So this is services. There's one service called load queue from cache. So now we didn't figure out how we are going to load the links on the queue. So you can load the links in any way. What I'm doing is I'm writing this function, which I'm going to call, and it will load the queue from a file. It will read a file containing links, and it will populate our queue. So the links reside here, storage, Udemy links.txt. So these are the links of the Udemy API, right? There are a lot of links. I'm not going to call all of them. We're just doing a demo. So you can read, I'm reading from this file and I'm loading each link onto the queue. All right. So that's the idea. So I'm going to call this function here, this load queue. Load queue is going to be called here. And send message is going to send a message to SQS, write to SQS. And this wrapper is written in some other place in the code base. All right. So this is the outline. And if somebody wants to pause me and ask me something, I'm more than happy to answer at this stage. We are going to run and we are going to see how things go. It seems like people won't have questions, maybe. So how do you deploy this? Continuing my session now. So you deploy it by a command called SLS deploy. It's that simple. You run this command and it will deploy everything, this code base, Lambda functions, SQS, attach, everything by just one command. Serverless framework handles it. So let's run SLS deploy. It will take some time because deployment will be a little slow. Should take a few minutes. So you can see something, it creates a stack. A stack is basically a bunch of resources logically organized together on AWS. So it creates a stack of resources that we are going to use. So in this case, it's going to be 2 Lambda functions, 2 queues, and a bunch of other things in the background, which I have not discussed right now, but a stack contains a lot of things. And yeah, it will create this stack. So stack create finished. All right. So, okay. I think I ran this command in a different folder where I was not supposed to, but that's all right. We will go back to the folder that I'm talking about. I was on a different place in my terminal, but no problem. I've already deployed this stack, but this is how it looks like. You will basically be able to see a bunch of things like this. Stack creation finished, uploading this file to S3. S3 is your file storage on AWS. Uploading the service, validating some templates, etc. It will tell you some information, your service name, the stage, the region. It starts with US East 1 as default. Test dev 6 resources, it deployed 6 things apparently, so on and so forth. So this is how the SLS deployment works. It's very simple. It just looks, you don't actually see things happening. That's why sometimes it doesn't feel like it, but a lot of things happening behind the scenes. So I'll close this terminal and I'll go to the original terminal that I was supposed to be on. All right, so let's do it. Okay, fine. We are on this thing. Things are deployed. What I'm going to do is I'm going to run this function and I've connected it to a database. What I can show in this demo is data being populated in the database at the end of it. So I'll try to do that. So I'll stop sharing this and I'll share my database editor screen. All right, so this is, yep. So this is my editor, MySQL Workbench, plain old good. And this is some database that I've already created. Again, not going into details, but there's some database. And we are, as I said, we were going to load courses, Udemy courses specifically. And there's a table called course table. I'll first clear it out. So these lines will clear out the tables basically for us. All right, so it's empty. Select star from course. If you just know a little bit of SQL, this is going to select everything from the course table. There is nothing here, right? And then we'll just load this. So I'll quickly go to the code editor and I'll just run the command load services. All right, so we should start seeing some courses. Let's try to see what happens. Yes, we immediately see courses, right? And you can see there are 219 courses right now. So this is very fast. And I mean, since it's just an API call, it's blazing fast, but sometimes it can be slow if you're doing some other kind of tasks. So right now there are 219 rows, there would be more, right? It would get loaded with time. 998 rows. So that's more and more data coming in. I'll show what it looks like in the logs. It doesn't look like much, honestly, but yeah, if you're debugging, you will feel what's going on. Okay, I think that might be all the courses. Let's see. Let's select the count of the courses. Right, it's 998 courses. I think that's the amount of courses I have kept for loading. I'll just run it once more. Okay, yeah, I think that's that. And I'll stop sharing this editor. Sorry, the MySQL workbench, and we'll quickly go to AWS in a while. You share, and then we'll share AWS. So what can you see in AWS? Well, while the links are loading, you could look at the queue, and the queue will tell you the number of links currently active in the queue, the number of messages. So that is something you could look at, although it doesn't look like anything. But you can always observe the logs. So we'll refresh the logs, and I'll show the scrape data logs. So it's timestamp based. This is just the current timestamp. It's 7:30 approx. So it's scraped right now. And yeah. So these are the logs that I'm logging in my code. It depends on what you have written, but what I have written is something like this, where I'm just showing, yeah, so this just shows the status flag. 0 means all okay, no errors, and result is the course ID. And this is just the response from the database, basically. So this is just a bunch of courses that are pushed into the database. If you look at the other logs for this, a scraper, you would be able to see again the same timestamp. Yeah, you could see a little more information here. This is the info that was scraped, right? This was the scraped data. This was what was fetched from the API, the title, short description, provider, author, etc. So you can imagine you could design any kind of a task that you want and orchestrate them through such a setup using serverless, using message brokers, using basically cloud tools like this. And this can really increase your throughput. It can really make your system scale. You don't have to worry about the number of functions you invoked. So I'll show you one more interesting thing. Let's look at the number of function calls that were made, because you can see it in the statistics. So these are the two functions. Let's look at this function. You can look at the monitoring section, and your monitoring will show you some information about the function. So CloudWatch matrix, this shows you things like invocations, how many functions were called. So you can see it's showing in UTC, but you can do plus 530 or something. And over time, there have been some number of invocations of this function, the duration for how many seconds the function is running, the error rate, how many functions failed or succeeded, and stuff like this. So you can use these matrix to monitor what's going on. These matrix are very powerful because you can automate stuff. You can put alarms. You could say that if there's a failure, notify me on my mail or notify me on Slack. You can do ton of integrations. So AWS is amazing. Such cloud platforms are amazing at handling stuff like this, where you don't have to manually configure things. You can very easily deploy your code and just see. The idea is you should not have to worry about the plumbing. You should not have to worry about your infrastructure. You should only focus as a software developer. You should only focus on an application and trying to scale it. Yeah, so that's that. I think that's a conclusion to my talk. I'll stop sharing the screens and I'll get back to the normal call. This is an end to the call, and I think if you have any other questions, anyone, you can put it up and ask me anything, basically. So we will,
Oh yeah, Nisarg, there was a question from YouTube chat.
yeah, what was the question? One sec, I'll just look at the chat. Just a minute. Is my screen still shared? No, right?
No, it's not sure.
Okay. Okay, so Ameya has asked a question. Can you explain how the idea of a queue and async go together? Okay, so the idea of asynchronous is that you don't have to synchronize your actions. You don't have to synchronize module 1 and module 2. You can just run a module. It does something. It's still dependent on the second module, but it's not forcing the second module to do something, right? And how can you do this? So you have to allow the second module to run independently on its own at a certain stage where it can, because the first module might be publishing 1,000 records in a minute, but the second might just be able to process 10 records. So asynchronous is the idea where you don't synchronize these modules together, you don't tightly couple them, and to decouple them and to make them asynchronously executing, you need some kind of a communication channel that allows you to delay your communication, that allows you to pause, that allows you to buffer. It's the idea is similar to buffering. And that is where SQS comes in. Your SQS allows you to buffer your messages, and you can at some later point process them at your pace. So that allows you to run it asynchronously. That's the idea. I hope that answers your question. If you have any follow-up, you can put it in the chat.
Yeah, I had a question.
Yeah.
Yeah. So suppose I wanted to have, say, like multiple Lambda functions to concurrently scrape data, and also maybe multiple Lambda functions to save data. So like in this case, how will the architecture diagram change? So will we still be using SQS, or should we use something else?
Okay. So the thing to understand here is when we say that there are multiple Lambda functions, what I understand when you say that is the same code is running multiple instances of it.
Yeah.
Same code. Yeah, right. So that is exactly the current setup right now also, where what's happening is whenever there is a message, the queue will make a function call. It will just call a Lambda function. And even while that function is executing, if you get a second message, it will call the second function. It will spin up a new instance of the function. And it can do that in theory at an infinite scale. Like AWS itself can handle millions of functions in concurrent, but generally you have much bigger constraints. AWS will never be your constraint. So what you are saying is already there in the current setup. Actually, right now, if you push 10 messages, there might be 10 functions running in parallel. And you can immediately see the power of this because your average processor has 4 threads. It can run only 4 things in parallel at max. But here you can almost do thousands of things in parallel. So that's the power of like serverless, right? You are not running it on one server, and AWS is managing the idea of running these separate functions somehow for you.
Right. And so if we have, when we say we are spawning multiple serverless functions, is it like usually in the same, say, same system, or is it like spread across many systems?
Cool. So the idea is, what happens is, how this internally works, how Lambda functions internally work is on one VM, or could be multiple VMs, each Lambda function runs in a container. So internally they use something like Docker. So they will spin up a container around your function, and they'll spin up one container and allocate your one request to that container. So you have multiple container instances running on a VM, and obviously a VM has its capacity. So if at some point it's overflowing, right, you can't run more than, let's say, 10 containers on one VM, then it will run it on a separate VM. Internally, it would manage a node, a cluster of VMs, onto which it would be running multiple containers, which are your functions. But it's all hidden from you. You don't get to see the containers or even control them. That's managed by AWS. That's the idea.
Right. Okay. Got it.
There's one more interesting point to note here, it's a minor detail, but it's something that if you actually go and write an application like this, it will trouble you. It did to me, which is that it's not a one-to-one mapping. You are not going to get one message assigned to one Lambda. What SQS will do is it will bunch together some number of messages and pass that bunch of message to one Lambda. So in your code, you are supposed to handle it. You're supposed to iterate through the bunch of messages and process all of them. Now you can set the number of messages it can bundle, right? You can set the bundle size, so to say. It's called the batch size. There's a parameter. So you can set the parameter to its default 10. So at max, SQS will bunch 10 messages and pass to one Lambda. But you can do it one-to-one. You can say batch size is 1. So SQS will always invoke one Lambda per message. I'll not go into the trade-offs. If you want to know the trade-offs, you can PM me and we can talk about it. But
Right.
it has interesting trade-offs. You should not ideally run 10 batch size. It has a lot of problems. And you should not run 1 as a batch size. That also has its problems. But yeah.
Right. Cool.
Yeah. All right. Any other questions, guys? All right. Yeah, I guess if there are not any other questions, we can end this call. And yeah, if you want to talk more about this concept or things around this, then you can definitely message me and we can have a chat or anything like that. Not a problem. Yeah, that's pretty much it. I'll wind this up and I'll end this call, I guess.
Yeah, thank you so much. It was a very nice talk. But then, as a beginner, how to get started with this? Like, should we be familiar with the app development and stuff and then get started?
Okay, that's a very valid question actually. Like as a beginner, even I did not understand what to do. So yeah, the thing is, you don't need to do any kind of app dev or web dev because you can clearly see none of that was involved in this. It just requires you to have some kind of a task in mind that you want to carry out and that you want to do. Generally, I would say honestly, I myself might not have been able to do this if I was not working on some particular project. This idea did not come to my mind directly because we are not generally aware of these things. So a good starting point would be to actually either come up with a personal problem like this, just make up a project that you want to work on, a data scraping pipeline, a video optimization pipeline, an ML pipeline, something like that, and try to build something around it like this. Or if you're working with some kind of a startup or some kind of a company in some kind of an internship sort of setup, if they are working at a even like small to medium scale, they might have some tasks like this. Every company requires things like email notifications or processing of user data, image uploading, some basic tasks. So as a newcomer, as a beginner, you will do it in the naive way. You'll write a simple code, a script that does something. but try to apply these concepts even in that, even if it's at a small scale. But it is something that will help you to think of problems at scale. So that could be a way to start. Now, obviously, you need to learn some of these tools like AWS itself, serverless framework, a little bit more comfort in that, maybe even be comfortable with writing code in a language like JavaScript, Python, something. So that is going to be there, but you could take up a project and, work your way through it. That's the idea.
Yeah, good.
Okay, cool. Thank you. All right. Yeah, guys, any other questions? Anyone? I think probably not. Yeah, I think we can end this stream.